Hey guys, Mr. T here. This is another video. This one is on drawing quadratics, but a different technique where you find the direction, the intercepts, vertex, and axis of symmetry, which I'm calling DIVA. So this is a more efficient method of drawing quadratics because with the table of values, obviously that can take a very long time. This way, you're finding some important points that define the curve of a quadratic. So what are these points where... well, points of interest really, the direction of the curve, so whether it curves upwards or downwards, concave or convex, the x and y intercepts, the vertex of the curve, so the tip or the turning point of the curve, and the axis of symmetry of the curve, because all quadratics, they're symmetrical on the left and right side of a vertical line. So to find these, you use the steps below. So even though I call it DIVA, it's actually DIAV because you have to find the axis of symmetry first, but we'll get to that. So direction of the curve. Given a quadratic in this form, most of the time you're going to want to put your quadratic in this form, y is equal to something x squared plus something else x plus a number. If a is less than 0, so if a is negative, then the curve is concave. And what do I mean by concave? Concave is the curve is the hump or the turning point is pointing upwards, so it looks like the mouth of a cave. That's concave. If a is greater than 0, so a is positive, then the curve is convex, so it's curved down that way. So all quadratics are in one of those two directions. You just look at a, the number in front of x squared, and look at whether it's positive or negative, and that'll determine the direction of the curve. Now, second thing that you're looking for is the intercepts, the I in the DIVA. So the intercepts. The y-intercept of the curve, so where it crosses the y-axis, is found by substituting x is 0 into the equation. So you look at the equation and replace anytime it says x with a 0, and then you work out what y is. And that's pretty easy, that's just substitution. However, finding the x-intercepts, that's found by making y equals 0, and this is more difficult because when you've made y equals 0, then it becomes a quadratic equation, and you have to solve the quadratic equation to find the values of x. You can have multiple values of x. After that, you find the axis of symmetry. So the axis of symmetry is a line that's got the equation x is equal to negative b. What is the b referring to? It's b in the quadratic when it's written in this form. So the number in front of the x term, so negative b divided by 2a, and a is the number in front of the x squared term. So x is equal to negative b on 2a, given the quadratic has the form this. Alright, so why that doesn't look like a line equation? Yes, it is, because it's a vertical line. So the only thing defining a vertical line is its position on the x-axis. So that's the axis of symmetry, and you actually do that first before you find the vertex, because you use this value of x to find the vertex. The vertex, the turning point of the curve, is found by substituting the x that you found here for the axis of symmetry into the equation to find y. And this, when you've done that, that gives you the x and then the y that you found by substituting. You get this pair of coordinates, and that tells you where the vertex is. So right now you got these 4 steps. They look pretty complicated, but as you can see from this, it's not too bad. So keep in mind the idea of DIVA, direction, intercepts, vertex, and the axis of symmetry, but also keep in mind that when you're actually doing the maths, you do the axis of symmetry first, because the axis of symmetry is used to find the vertex. So let's do it in order. 1, direction. How do I decide the direction? Look at the equation. What is the coefficient of x squared? It's 1. It's just not written there. Positive 1. A is 1. Therefore, curve is convex. It's pointing down. So that's direction done. 2. Intercepts. So start with the y-intercept first because that's easier because it requires substitution only. So the y-intercept happens when x is 0. So substitute 0 wherever the x is. That's 2 lots of 0, take 3. 0 plus 0, take 3. Negative 3. So the y-intercept is at negative 3. X-intercepts. How do you find the x-intercept? Make the equation equal 0, so make y equal 0. And then you got x squared plus 2x, take 3. Now you solve the quadratic equation. And how do you do that? You factorize. So you look at this number. I'm going to do sum and product rule because I can see that it's going to be sum and product rule. What are two numbers that I can times together to make negative 3, but add together to make positive 2 here? Negative 1 and 3. So the equation is going to factorize to x take 1, x plus 3 is equal to 0. So now we have null factor law. X minus 1 could be 0, or x plus 3 could be 0. What's the opposite of taking 1? Adding 1. So x could be 1 left, or it's the opposite of adding 3, taking 3. So x could be negative 3, the other alternative. So those are the two intercepts, the two x-intercepts. Now we have to find the axis of symmetry. So 3 axis of symmetry. The axis of symmetry equation is x minus b on 2a. B was 2, so it's negative b, so it's negative 2 on 2 lots of, and a was 1, so it's 2 lots of 1. So it's negative 2 on 2. So the axis of symmetry is that x is equal to negative 1. And lastly, the vertex, we can do the v now, because we found the axis of symmetry. The vertex, how do I find the vertex? You substitute the x you found in the axis of symmetry into the equation and find y. So the x for the axis of symmetry was negative 1. And the original equation was x squared. So it's negative 1 squared plus 2 lots of negative 1, take 3. Negative 1 squared is 1. Positive 2 times by negative 1 is negative 2, take 3. 1, take 2, negative 1, take 3, negative 4. So these two steps tell us that the vertex is at negative 1, negative 4. So now we can graph this quadratic. Just put that there. We've got a few points of interest that will let us graph it. So they are the vertex, the x-intercepts, the y-intercept, and keep in mind the direction. So I need to have a grid, a set of axes. There's one. There's another. I'm going to go up by 2 each time, so it's a bit easier to see. 3, 4, 1, 1, 2, 3, 4. Okay, let's plot our points. So the y-intercept is at negative 3. So where it crosses the y-axis is at negative 3. So negative 1, negative 2, negative 3. The x-intercepts are at x is equal to 1 and x is equal to negative 3. So x is equal to 1 is here. X is equal to negative 3 is negative 1, negative 2, negative 3 here. And the vertex is at negative 1, negative 4. So negative 1 and down to negative 4. So you'll be asked to label these, so please do. Vertex, that's the y-intercept. It's x-intercept, and there's the other x-intercept. And you can already see that this curve is going to be convex because the vertex is the turning point down here. It's going to curve up this way. And then it's going to have the same curves. And you just need to make sure it's symmetrical along the axis of symmetry. So the axis of symmetry is at x is equal to negative 1. So that's here. I'll put the numbers on the axes later so it's a bit easier to see. So just make sure it's symmetrical about that axis of symmetry. So there we go. And then just continue the curve up. We don't have any other points. So just continue the curve up nicely there. And just try to keep it symmetrical. Alright. So just adding my numbers here so it doesn't confuse anyone. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. Negative 1, negative 2, negative 3, negative 4. And 1, 2, 3, 4. So that is using the DIVA method that I've made up. It's an amalgamation of a bunch of different steps, but I've just put it all into one and given it a nice name. So that is using that method to find or draw or sketch a quadratic on a grid using a few points rather than a whole table of values. So hopefully that makes sense. Hopefully that helps you out. And I'll see you on the next video.